So this is where things get a little bit more entertaining. What we're going to talk about today is volumes. Instead of area, we're going into volumes, and we're going to create our volume today by rotation. What that means is I'm going to take this area that we see here, and I'm actually going to rotate it 360 degrees around the x-axis. Okay? So visually, if I can kind of get us a little bit of a graph of what's happening here. So when I rotate this around the x-axis, we're going to see that reflection there. And what's going to happen is we're going to create this circle. Okay, anywhere here, we're going to have these little discs. So if you remember, like this is way back in the day, this is going to make me sound super old. When you would buy the CDs and they would be in a stack, they make like this really cool cylinder, but individually, each CD has its volume. And that's what we're going to look at today. Each one of these discs has its own volume. If we look at the base, we're looking at a circle, right? And we know how to find the area of a circle because that's what we're looking at. That's going to be pi r squared, so whatever our radius is. And then if we give this just the smidgen about of depth, that depth is going to be our change in x, right here. Just a little bit of depth to each of our discs. When we add those together, we're going to get this full volume that we've rotated around the x-axis. So when we set this up, we're going to have an integral from a to b. Pi is always just a constant multiple, so we're going to pull that out front of our integral. And I'm going to have my radius squared dx. So my goal here is just to determine what is my radius. So if we look at our first example, the radius is going to be from your line of rotation, and in this case, to my function. And my function is x squared. So here, my radius is simply my function, x squared. So I'm going to have pi r squared dx. And since they told me we cut this off at 2, I'm going from 0 to 2. Okay? And if I simplify that, I'm now looking at the integral times pi from 0 to 2 of x to the 4th dx. And now it's just solving an integral. Here is the volume of my disk, area of the plate, the base, times the depth, pi r squared dx. So when I anti-drive this, I'm going to get x to the 5th over 5 times pi, evaluated from 0 to 2. So 2 to the 5th, that's 32. So this is going to be 32 pi over 5 units cubed, because now we're talking a volume. If you can kind of imagine this horn-shaped type thing right there, that's what we're looking at. Okay? And just like we talked about a little bit with area between curves, what happens if we're in terms of y, or if we have a left side bound, right side bound instead of upper and lower? So I've got a second example here, but instead of rotating around the x-axis, I'm going to rotate around the y-axis. So I'm going to take this shape and rotate it this way. So we're actually going to see the reflection come in something like this, and I still have all of these little discs. Okay, but now our depth is dy because we're stacking them like this. So we need to write our function in terms of x. No, in terms of y. In terms of y. So I'm going to take this y, and I'm actually going to isolate the x. So the square root of y equals x. When we square root that y, we're going to have the plus side and the negative side. But since we're rotating and getting that reflection, we can go ahead and ignore the negative. Okay? So here, my radius is the distance from the y-axis to my function, which is the square root of y. So pi r squared, give it a little bit of depth, dy. And since we're stopping at 4, we're going to go from 0 to 4. And now we just got to solve. So square root of y squared, that is just going to give me this y. And I anti-drive. So y squared over 2 times pi from 0 to 4. 4 squared is 16, divided by 2 is 8. So this is 8 pi units cubed, because we're talking volume. Okay. Yes, this can get a little bit more complicated as we deal with our functions, but discs are pretty straightforward because it's just a solid circle, finding the area of that circle. But what happens when it's not solid? Check back for the next video and I'll show you how to do it.